Hello guys, welcome back to Tronic Synergy, and today we are doing a half adder circuits using some two special logic gates that we have here. So this is our circuit and it's going to be performing some binary addition of single binary codes which are only 0 and 1. So my input side is right here, then the logic gates are right here in this integrated circuits, and then our output is right here. Green LED shows the summation and the yellow LED or orange LED shows the carry signal. So in a normal system, the binary addition is done is usually in the form like this. So 0 plus 0 is equals to 0, 0 plus 1 is equals to 1, 1 plus 0 you get 1, and 1 plus 1 you get a 0, carry 1. So my input side is like my input side is okay, my circuit is just created the same way as the form that you're seeing right there. So let's try it. So it's already on. So 0 plus 0 you get a 0. So let's do 0 plus 1. So this side I put a 1, it's on. So 0 plus 1 you get a 1, there you have it. Then I turn it back to 0. Then next I get 1 plus 0. So 1 plus 0 you get a 1, yes. Then next I do a 1 plus 1. So this is on, so I turn this on. Then I get a 1 plus 1, I get a 0, carry 1. And that's what we are going to do today. Welcome back, and today we are going to do this half adder circuits. It's very easy. It's an easy circuit, and it's the basics of what modern computers use in terms of data processing and other operations inside it. So now we're going to start with the half adder. Next I'm going to do a full adder, and then we are going to proceed from there to other more complex circuit in the future. So today we are going to do this. So it's a pretty easy circuit. We are just going to be majorly looking at these logic circuits right here. So this connection right here using the NE555 is just a simple connection. It's a bistable connection. I have a video that I posted on how to connect an NE555 in bistable mode, and it's not a big deal. What it means is that I've connected it in a way that the output is controlled by two switches. So switch 1 is going to turn the output on, and switch 2 is going to turn the output off, the same as to this other circuit. So the function of these two NE555 is just to switch these two, just to give the two inputs A and B to these logic gates right here, so that they can perform the addition, the half adder configuration of our circuit. So that's basically what these two NE555s are going to do, and they have an the output is also connected to LEDs, which are going to show what's the output of our NE555. So it's going to show whether it's on or off, or whether it's giving a 1 or a 0. According to our circuit, because we are going to add binary numbers. So in a normal system, we get that I've written it here. Normal system, you get the addition of binary numbers. 0 plus 0 you get a 1, 0 plus 1 you get a 1, 0 plus 0 you get a 0, sorry, 0 plus 1 you get a 1, 1 plus 0 you get a 1, and 1 plus 1 you get a 0, carry 1. So our output is right here. So the output of this XNOR, this is an XOR, sorry, this is an XOR logic gate, and this is an AND logic gate. So our output of our XOR logic gate is going to give us the summation of what we need. Then the AND gate right here is going to give us the carry. So this carry, you see this carry, so 1 plus 1 is equal to 0, carry 1. So it's going to be on, showing you that the inputs are both on, so we get a 0 and we carry 1. So that's basically what our circuit does. So yes, so that's basically what we are doing right here. So you should check. I'm going to put a video showing you how you can make a simple XOR gate. I think I did the other logic gates, but the one I didn't do is an XOR gate and an XNOR gate. I didn't do, so I'm going to do these two, and I'm going to post them very soon. So yeah, but for now I'm just using integrated circuits. I'm not using transistors. The other time I was using transistors to make these logic gates, but now I'm using integrated circuits just to save time and to save the space of my breadboard, and because connecting these logic gates using transistors is really it really needs a lot of transistors and a really good way of understanding these things. So next time I'm going to do them with the transistors, show you how easy it's just easy connection, only that it needs a couple of transistors in order to make these circuits. Like for the AND gate you need only 2 transistors, but for the XOR I'm not pretty sure how many transistors you need, but I'm going to check, and next time I'm going to do them with transistors. Yes, so that's basically what we are going to do. And these are green LED, these are orange LED, so the output, and they have 1K resistors just for the protection of the LEDs. So my circuit is right here. My power supply is right there. Is a 5-volt power supply, the one I'm using. You can use any from 3 to 9 volts. Yes, but you should check the ratings of these integrated circuits in order for you to not overcurrent them or over voltage them. So yeah, so there's my circuit, and you can see just the same connection as my schematic. The 2 switches of the first N55 are right there, 2 push buttons, and the other one are right there, 2 push buttons and the N555. The output LEDs right there. I'm using blue LEDs. You can use whichever ones that you have to show the output. Then yes, so from there the outputs, this N55 gives the inputs of the logic gates A and B, and my logic gates are right there. I have 3 integrated circuits, so this is a NOT gate. Integrated circuit is an hex inverter, meaning that it has 6 inverters inside. This is an AND gate containing 4 AND gates, so I'm using 2 of them only. And this is an OR gate containing also 4 OR gates, but I'm only using 1 OR gate in order for me to connect to get an XOR and an AND gate, for me to get the carryout and the sum output. So my outputs are right here. This is a green one showing the summation, and this is the orange one showing the carry output. So I'm going to power my circuit, and we are going to check how it performs, if it performs to this standard. So our standards are right there. Let's see if it's going to perform like that. So it's on. Yes, it's on. So already it's on. So 0 plus 0, we get a 0, and there's no carry. So our first configuration is correct, so we can proceed. Then we do 0 plus 1. So this side I'm going to leave it like that, but this side I'm going to turn it on using this push button. It's on. Then 0 plus 1 you get a 1, and there's no carry. So the green LED is the one that is lighting only. So yes, so that's correct. Let me turn it off. Yes. Then we are going to check 1 plus 0. So the first side I'm going to put it on, and the second part I'm going to leave it like that. So 1 plus 0, we get a 1, and there's no carry. So 1 plus 0, we get a 1, and there's no carry. So that's correct. Then our last configuration is the 1 plus 1. We should get a 0, then carry 1. So we expect our orange LED to be on. So I'm going to just put this on, and it's on. So immediately it's on, the green LED is off and the yellow LED is on, meaning that we have a carry. So it's 1 plus 1, you get a 0. Green LED is 0. Then it's off, so meaning it's 0. Then we get a carry 1, orange LED. So that's basically how the circuit performs. Just an easy circuit called the half adder. Next time I'm going to do a full adder. I think a full adder is much more complex than the half adder, because it needs some addition of the logic gates in order to get the various outputs. So this is a half adder circuit, and I hope you're going to try this at home, and share this video to as many people as possible for them to learn with us how to make these circuits. So we're going to do that again. Let's do that again and check. So I'm going to turn my inputs off. Then we do that again. So 0 plus 0, we get a 0. Yes. Then we're going to check 0 plus 1. So 0 plus 1. So I'm going to turn this on. We get a 1, and there's no carry. So that's correct. Then I turn it off. Then we have a 1 plus 0. So this side I put it on. Then 1 plus 0. This side I leave it off. We get a 1, and there's no carry. Yes. Then our last configuration is 1 plus 1. So this we leave it like that, and then we turn this on to get a 1. 1 plus 1. We get a 0, carry 1. So yes. So thank you very much guys for watching. Please subscribe to Tronic Synergy, where we do fun stuff all day, all time. Next time we're going to do a full adder, and then we're going to proceed doing more complex circuits in the near future. So thank you very much for guys for your time and for watching. Please share, like and comment